Hi, Teacher Ian here. What's the difference between alkaline and acid? Now, at the heart of the difference between alkaline, which is often called basic, and acid is a fundamental chemical tug-of-war involving a single element, hydrogen. Whether a substance is an acid or an alkaline depends entirely on what it does with hydrogen ions when dissolved in water. Let's look at the molecular difference. So to understand how they behave, it helps to look at the chemical definitions. Acids we could see as the donors. An acid is a substance that releases hydrogen ions into a solution. These free-floating hydrogen ions are highly reactive, eager to bond with other elements, and can aggressively break down materials. Alkalines or bases are the acceptors. An alkaline substance is a base that dissolves in water. Instead of releasing hydrogen, it releases hydroxide ions, or eagerly absorbs free hydrogen ions. Hydroxide ions are essentially the cleanup crew for free hydrogen ions. When they meet, they combine to form perfectly neutral water. The pH scale. So to measure how acidic or alkaline a liquid is, scientists use the pH scale. Potential of hydrogen. It is a logarithmic scale ranging from 0 to 14, meaning each whole number step represents a 10-fold change in intensity. So in the pH range 0 to 6.9, things are classified as acidic. What is happening? There's a high concentration of hydrogen ions. Battery acid or lemon juice are two examples. In the pH range of 7, this is neutral. It's a perfect balance of hydrogen and hydrogen oxide ions. Pure distilled water is a good example of this. And 7.1 to 14 on the pH scale is alkaline, where there's a high concentration of hydroxide ions. Blood, soda, those are examples. How do we tell them apart by their properties? If you encounter an acid or an alkaline solution in a lab, a kitchen, or a workshop, they exhibit starkly different physical characteristics. Acids taste sour like vinegar or citrus fruit. The texture feels sharp, wet, or stinging on the skin. And their reaction with metals, acids are corrosive, and many acids react vigorously with metals like zinc or iron, releasing flammable hydrogen gas. The litmus test. Acid turns blue litmus paper red. Alkalines taste bitter, like unsweetened cocoa or soap. Their texture feels slippery or soapy to the touch, and this slipperiness occurs because bases immediately begin to break down the natural oils on your skin in a mini chemical reaction called saponification. That's the way soap is made. There's a strong reaction with fats. Alkalines are highly effective at dissolving oils, grease, and organic fats. The litmus test: alkalines turn red litmus paper blue. And remember, blue for base. The chemical climax: neutralization. When you mix an acid and an alkaline together in equal strengths, they completely destroy each other's properties. The H and the OH rush together to form water, leaving behind a completely neutral compound called a salt. So, for example, if you mix burning hydrochloric acid, HCl, with corrosive sodium hydroxide, NaOH, a strong alkaline, they neutralize into harmless salt water, H2O plus NaCl. And there you have it. We all know a bit more about acids and alkalines. Don't forget to like and subscribe. See you in the next one.